Hello and welcome back to compiler programming. I thought it's time for us to start actually trying to use the language that we are building, and there is a sort of rite of passage for every new programming language, which is implementing a Fibonacci sequence. Because it's usually implemented in a recursive way, and that means that it really stresses how the management of the call stack is handled, whether all the arguments are correctly passed and returned, and stack is correctly reserved and cleaned up, and so on and so forth. This will really just check out if all of the stuff that we've been doing till now actually works. Just for clarification, this is the mathematical definition of what we will be trying to build. So it is rather straightforward. We just need to have if statements because we need to kind of switch on the value, and we need to be able to call functions and to do sum, which all of what we already have. So let's just try to basically straightforwardly implement this definition. It should calculate Fibonacci numbers. Okay. We need the function fib, and this function will just straight up transcribe what's written in Wikipedia. So we say if ic, so we need an argument, and I will just use 64 bits. It's fine, it could be 32. We can also try to play around with that size to make sure that it, for example, works for all of them. So we say arg s64 of, let's call it n, since that's what they call it. So it's arg s64n, and we say if n equals value from s64 0, then what we do is we return value from s64 of 0. Okay. Now we have the second one, which says if n is actually 1, we return 1, and we could technically try to also optimize this by doing like OR and say if n is 0 or 1, but we don't have OR yet. Maybe something that we could add in the future. For now, I'm just sticking with textbook definition in Wikipedia. Okay, if it's none of those, then we need to recurse. And this will introduce the first challenge for us because we don't really have a way to refer to ourselves inside of the function. And this is a pretty standard problem actually in compilers. And some of the older languages, they had like, they either didn't support recursion altogether, or you would have some special form. I think in Lisp, like you have, for example, let to define something, but if you wanted something recursive, you need to say let rec, and that does special transformations on the code to allow you to call yourself. And there is various interesting computer science things around, for example, how to transform recursion into non-recursive versions and so on. So anyhow, we will support recursion. And the way I'm thinking of doing it is to introduce a special macro that will be called self. And I'm not sure if we want let's do it without arguments. So it will look something like this. We are actually, since we have the fib here, we could even we could even probably do correct variable. So then let's do it like this. Call function value of builder. Now we need a value. Let's say that we will use ourselves, and the argument will be, we need to create that argument. Actually, no, argument is n, and or not, no, argument is going to be n minus 1. So we need to create this. Let's say stack s64 minus 1 is minus n value from s64 of 1. Okay, something like this. Then we do minus 2, and that's n minus 2. Now we can call with like so, I believe. I already forgot how our stack stuff works, but let's just say it's like this. And then we need to pass in, I believe, the argument count. So this call function value is definitely something that we can and should improve. Okay, so now we say return. Let's try to write it without extra temporary values, because it will also check how good is our temporary value allocation is. So we do plus, right? And then call function value like this and like this. So just writing over the thing over here, right? So we do -1 and -2. It's a bit unfortunate that we can't really use this version, probably. Actually, no, I think we can. Let's try that. Let's just say that we can, and we'll make it happen. Okay. So syntax error, probably have too many of those. Yes, I do. Okay. Well, it's built, but the question is, does it run? Okay. Let's see. We can now convert it to a function, and we say fib, or we call it here value as function, fib, function type, what is it, s64 to s64, and we call it, well, let's just do it one by one. I will turn it into a variable because we will call it a few times within the test, and it's just more convenient to have it this way. Okay. I will immediately call it f. Let's say check that f of 0 is 0. Right? That's a definition. F of 1 is 1. And f of 2 is 1. F of 3 is 2. And so this is this is 0, 1, 2, 3, 4, 5, 6. Let's just do f of 6 is 8 to try to recurse a few more times. Okay, well, let's see how spectacularly this explodes and go from there. Okay, so it explodes when we try to compare a register with an immediate value, which we do not support at the moment, but we can check if this is something supported at all. So yeah, it looks like we can't. No, this is the wrong thing. We need compare, and compare is there, at least for 32-bit values. So we again ran into that whole dance with the fact that you can't really have immediate 64 values with most encoding, so you have instead 32-bit extended to 64. This is something we probably will have to take care in a more organized manner, but for now this is not what this video is about. So instead we are gonna fix our encoding. Let's search for SCMP. Okay, we have register memory immediate 32, and that means that the actual encoding that we want is there. However, we cannot use it. So there are a couple of ways I could fix this. One way would be for us to change these, for example, to 32-bit, but that's a bit of a cheating. So instead, let's look at our EQ implementation. And there we could add a special helper. So Q is compare, yeah. And here we can do what? Here we can change comparison to be more robust. So we already use register A for one of our values. So if we just use memory for another one, for example, this version of the instruction, then we could not, like we will not need to worry about the immediate, or at least partially, because technically we would need 2 registers to completely avoid worrying about immediates, but for now we can deal with just one, right? So what we can do is we can say value star temp b is reserve stack. So this is going to be same as here, right? Reserve stack, and we say b descriptor. Now we do move value of builder, and then b or temp b, and once we have that, we can do the compare. Where is actual compare? I'm a bit lost, to be honest. Actual compare is happening here. Yeah. So this means that we need to change temp b to be like this, and this will probably also fail, but let's see. You cannot operand to be operand. That is true. Okay, let's check if that helped. Okay, it still says that it cannot find acceptable encoding, and it is now correct because we do not have it. We need to add this. And the encoding will be 3B. Extension type is register. Then we have register at the top and register memory as the second one. Okay, let's check this out and see how it goes. Okay, we are making progress. So our compare at least encoded correctly. Now we have the same issue with our subtraction, apparently. Where do we use subtraction? Yeah, it's gonna be in our minus, right? So where is the minus? Minus, 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 minus. It's a bit up, I guess. Yes. So this is our plus or minus. It complains that it cannot encode a register and immediate. Okay. What do we do here? Yeah, we have sort of the same issue that this cannot be 64-bit operand. So right now, let's just always create a temporary value. Same as we did there. Exactly the same thing. And this is why I say that we will probably want to do this more systematically. So I'll probably a video go through all of this function and just extract this logic into a helper to have it, and also make it conditional to only happen when we have immediate 64 values, because for immediate 32 we usually will not need this. Okay, anyway, stack reserve, builder, b descriptor, move value, builder, temp b, and now we can use temp b operand over here. Differs in with int. Did I mess up stack reserve? Oh, yeah, it's reserve stack. Okay, let's see what else fails. Did not find acceptable encoding. That is indeed a problem. So this is something we need to fix here as well. And how shall we do this? I mean, essentially it is the same thing as we have here. So we just add another case that says or a operand type is operand type memory indirect, and the same goes for B. So if both of them are memory, there are no such instructions anywhere in the x86 assembly. Like you can see, you always have memory on one side, and then either on the left or on the right. You can have immediates, you can have registers, but you can never have memory to memory copy, as far as at least I'm aware. Okay, so let's see if that helped at all. Well, we are apparently we broke something and we're crashing. This is not really great, but this is something we can clean up. And I guess we can start with the crash. And the crash is happening. Yeah, the crash is happening in the recursive part, because at this particular point, Fibonacci is null. And this is not really great. So we need to figure out how to make it, how to change our function macro to allow us to refer to the function somehow. So we start with value ID like this, and our return condition is that we have something inside of ID, but this is not how we would want to make it happen now, because right now we essentially need to do some of the work that we were doing only at function end to start doing it midway. And in particular, believe this code needs to go in there. Yeah. So this is will be a bit wasteful, because every time essentially we add an argument, we will do some changes, but in the end it is fine, I guess, for at least for now. So let's take this out. This is fine. So descriptor, yeah, we just need to update the descriptor. And builder, what does builder contain? So builder contains descriptor function, which is something that we can probably update as we go. So here we are returning. What if besides returning, we also update the argument count and update the actual descriptor? Okay, so this is function arg. We create a new descriptor. We say that it's a function descriptor. We copy in the builder one, and we make sure that there is a return value, and we need to stick it somewhere so that it works correctly. I guess one way to do it would be to store descriptor. So what we are doing is we are storing a pointer to the resulting pointer of this whole build process. And every time we will do anything to arguments, we will update that result with something. But before we actually do this refactoring, let me roll this back a bit and introduce something else. Right. Something did not go well at all. Yeah, because I misspelled descriptor. Okay, now it builds. And one thing I want to do before we do the big thing is to change the actual function to change how this works. Because now that will be the wrong condition for exiting the loop, right? We would want to exit after function end is called. And that means that I will need to add another field that is called bool done. And we just say here, if not builder done, then our function end no longer needs to return stuff, although actually it does, but it's fine. We'll also change this in a second, but one step at a time. Now function end will need to do things. In particular, function end now will need to say builder done true. Okay, that builds. Let's try it out. We had this failure before. Function remains as 32 value passed to it, so maybe let's look at that. At least we are not having new failures. Increments as 32 value passed to it. Increments as 32 value passed to it. Seems pretty straightforward. So let's see what's wrong with this function. By looking at the assembly. Assembly, ting, ting, ting. Okay, so we reserve some stack, we move it to one stack position, we move this one to another one. They are correctly sized, it seems to me, so they do have. No, I don't want to know. Whatever. Then we move one of them to EX, and then we immediately move another one to ArrayX, and also with the wrong size. So this seems indeed very, very fishy. Okay. This is not what I wanted to see. Let's check where this is happening. So, actually, let's not go out of this assembly so I can refer to it and see what's going on. This window a bit more and do it like so. Okay, what is our function doing? So we have stack S32, 1. So I think these ones are perfectly fine because these are these two things that are happening here. Now the next thing is what's happening is we are loading the value into EAX, and this must be the minus code, right? So let's look at plus or minus. This is what should happen. We do the assertion, so this is the issue because move value might also use register A to transfer things between memory and memory, and if we put stuff in there, it will obviously be overwritten with not the right stuff. I'm also a bit worried about the sizing here, so some of the moves seem to not do the right thing, but let's not worry about that for now. So, okay, let's run the tests again. It still fails, which is not great, but now we can look more at what's happening. Maybe it's that misalignment that is causing it to do wrong things. Okay, so I definitely want to see actually the register I can see here, and right now it definitely has wrong things, so ting ting ting. So this move does not seem to be right at all, and this is because it shouldn't be ArrayX. Instead it should be the same as we are doing here, value for register A. So it should be like this instead. To be the right size and operand. Good. Maybe that will help. Okay. That does help with a lot of stuff. At least it fixes our issue. So let's actually stage this, even though it doesn't work fully. And let's see where we are failing. Yeah, so now we are back to our Fibonacci stuff and back to the fact that we need to refer to a function before that function is actually available. We can fix that. That the idea now is we will kind of store the resulting pointer in the builder, and every time we change the builder, we will update that pointer. And later on, we can even add a check that verifies that we don't try to call ourselves or we don't try to modify ourselves after we have been called. So imagine that, let's go to Fibonacci. So imagine I tried to call myself over here, like before this argument. So imagine call will go here. Like this would be complete madness, right? This is not something that should be allowed, and we will be able to catch it later. But for now, this is not important. So let's go to define function. And as I said, now function begin will accept a pointer or it will accept a address of ID. That means that we will no longer return ID from our function end, and that requires a few changes. The first change is, as I said, function end now supposed to be void, and that will help us figure out what's supposed to happen. So in the first pass, I will not actually update it on every change to the builder, and instead I will only change basically the way we return and say here builder, so star builder result is result. So remember, this star, we are not writing to a value, we are writing to a pointer, like because we have double interaction here. Let's see what happens, and yeah, the result actually shouldn't be descriptor, it should be a value. You are right, the compiler. I was wrong. Let's see. Ideally, we should have exactly the same failure. We do not, though. We fail way earlier than that. Okay. What is happening then? Builder result was null. This is the first time we do function. Yeah, this is the first time we do function. So I screwed something up. Let's... yeah. That makes total sense because here I need to accept this. I think they are planning to change in the next version of C that if you have a function defined like this, you will not be able to call it with arguments. Instead, like I should actually be doing this because then this would catch it, and I probably need to get into a habit of doing it this way. But too much experience with other languages is not passing me by. So anyhow, result is a result. This is better. Let's check this out. Okay. We are in a good state. We again are crashing, but we're crashing in exactly the same place. So this is what we expect. Good. Now we need to take out this part and actually change things around. So the first refactoring that I will do is I will actually this happens in function end. Yes, that's fine. I will move this to function begin. And say here, so this is just basically will create memory for our result. It shouldn't really change anything. So we do star result is temporary allocate, and star result is this. Now we don't need to do this stuff, but we need to say actually star builder result descriptor is descriptor. I probably messed up some stuff. Okay, let's start from here. Builder undeclared. Yeah. First of all, this is now called builder, and it should be like this. Builder buffer. Okay, this is fine. What is happening here? Star builder result. I think I need some braces. Okay. So again, this should still be exactly. Actually, no. Now it should crash for a different reason. Actually, it should assert that we don't have the right number of arguments. Let's see if I'm correct. Well, apparently not. Apparently it explodes in a different place. Exception thrown at blah blah blah, access violation executing location. That is interesting. So yeah, that's obviously the and this is not even the first time we have a function. Oh no, we create functions but do not actually run them here. So let's, I'm curious, what is actually happening there? Okay, so we are just jumping in completely bullshit memory. Okay. What did I mess up? So we allocate a value and then we write well. Okay, let's remove a few labels and directions so it's a bit easier to read. And we say that star result is result. So doesn't actually change anything. I just want it to be easier to read. And here at the very end, we change the descriptor. But descriptor shouldn't actually matter here because the only thing that changes is actually also return value does change. But it shouldn't change the memory that we jump to. That seems just weird to me that this is happening. This is very, very strange. Let me try to figure this out. So the name of the thing is the answer. This is what it looks like. It is correctly a function descriptor. It has no arguments. It returns a register of size 4, which is correct. The descriptor is integer, so all of this is perfectly fine. The only thing that is messed up, it looks like, is the memory. So it goes to this memory. And how do I know if this is the right one or not? I guess let's step through the actual code that creates a function and see what is going on. So what I want to add now is I want to know what is the builder buffer. Oh, I think this is the issue. There shouldn't be yeah, there shouldn't be an ampersand there. And because we are doing a cast, it's perfectly happy to oblige. Okay, yes, that was the issue. Good. So now we are doing much better, but we still don't correctly update the function midway through so that we would be able to call it correctly. And the way we can do that is maybe create a helper and say function update result. Okay. This seems fine. And again, right now we will just call it from over here. Descriptor. Yeah, and this should be part of this code. Let's run the tests again. Okay, that's what I would expect. Now that we are here, I'm also thinking that we can allocate the resulting descriptor beforehand. Right? Yeah, that seems fine. And then in here, we would need to just do builder. Yeah, we don't even need to do this now. We just need to say what builder result descriptor function. So maybe we can do it like this so it's easier. Descriptor star descriptor, or result is this one, or result descriptor. Then we can do result descriptor. This one is kind of interesting because we can't actually do that until yeah, this is a bit unfortunate. This was dealing with the fact of how we are tracking whether we already did a return to do type checking on return, but now it's gonna cause some issues for us. That's unfortunate. I mean, it doesn't actually. It's not particularly a problem for this function. I guess what we can do. it's a bit yucky. I hate Boolean parameters, but for now it will help us move forward. So we just add another parameter, and we will pass this one only when we call update result at the very end. Let me say true. Okay. What I was doing, well, I was saying that result descriptor function is builder function. We leave it is like so. Function is not a member, it's called descriptor, fortunately. Builder descriptor. Okay. This seems fine, and probably this could be cleaned up a bit, but let's check that we didn't introduce any new issues. It looks like we did. So let's debug that one. Result descriptor function is builder descriptor. And we are trying to write to 0. Yeah, you're absolutely right. We are trying to write to 0. Let's try that again. Okay, this is a much better crash. So now we are actually catching, like now we can actually call the function. Let me say this version, and I will show you what is happening. So Fibo. So what is happening right now is that over here we try to call the function, but we are not updating the function every time we call arg. So when it tries to call it, it's like, oh, I'm calling this fib function and I'm expecting it to have 1 argument, but it tells me that it has 0 arguments because this was not updated until the very end. So I'm not gonna do it. Okay, so, but this we can fix rather easily. We just want to update function arg. And this is why this update result now is a separate function. And now that I'm thinking about it, we don't really need the boolean. We can just extract this into here, right? This seems much better than what I had before. So now I can do descriptor star. Result descriptor is this. Yes, I like this one. Let me, okay, we are still failing in exactly the same manner. That's good. Okay. Now in function arg, before we return, we just need to say function update result. And that's all that should be necessary for all of this to start crashing in a different place. Let's see. Builder undeclared identifier. Oh, this is one of the unfortunate remainder function that call this thing function. I should totally add multiple cursors at some point. So something else is happening. That's always progress. Let's see what debugger says is happening. It is crashing now in same type and plus or minus. That's interesting. So it's obviously still this line, and I might split this out into lines just so it is easier to debug. It won't actually change how our stuff is working, and we say -1 -2 register f -1 is this thing, and f -2 is the same but just 2. And then we can say result is plus of these two, f -1, f -2, and return result. Like this way, it actually didn't change at all, like how our compiler deals with temporary values, but it just, we are kind of working one level above, so it only changed how we can step through this code in debugger. Like, I'm not introducing temporary variables in our language, rather just in the C compiler. Okay. And this just allows me to do this. And apparently realize that that it actually blows up earlier. Source not found. What are you talking about? What is happening over here? I'm really confused. Can you please just break somewhere? Okay. So all of this is fine. And I guess some stuff is happening over here. Value from a 64 is all okay. Let me check what is. So in locals, I want to have n. N is a register, RCX, size 8. Looks pretty fine. Okay, so actual -1 and -2 are encoded correctly. So this is probably in here that things go haywire. Not really. Okay, so this is where things go haywire. And it tells me that both A and B are actually null pointers, which is fascinating. Let's retry that one. Just to me to see that. Okay. Okay, it's f minus 1 that is a null pointer. How does that happen? I wonder. I guess the issue is that builder right now is in a weird state. So let's see what's happening to the builder. Builder. Where is the descriptor? Returns. I mean, it has a return value. Why? But this, we should not look at the descriptor. We actually should look at this thing. And this thing might not have, okay, this thing does not actually have a return value. This is kind of interesting. So what happens inside function return? Yeah. Yes. So we need to update the builder not just in function arg, but also inside function return. Otherwise, bad things are gonna happen. Okay, even more progress. Now we are now the issue is that call function value does not actually store the value anywhere, and instead it directly returns array x. So this is something that we also should fix if you want to make our code more generic. And this is why I didn't want to introduce these temporary values in on the stack, because I want the code to work either way, right? Whether we introduce them or not. And right now it doesn't. And this is kind of bad, right? And this is the issue where we call something and then we return whatever the return value of the function was. And this is not cool. Instead, what we should be doing is we should be saying value star reserve result is temp allocate value, or actually no, it should be even value. It should be value for value register for descriptor, descriptor, and then I say register a, and descriptor returns descriptor, because returns is a value. Maybe I should call it return value, so it's not ambiguous in here. And we move value from value builder result descriptor returns and return result. Okay, that builds. So now we are basically forcing that every time we call a function, it returns us value right now, always in array x, but it might change. It doesn't really matter. We will copy it out on the stack so that we can free up array x for different things. And this is one of the ways that assertions like these sort of save you from very weird debugging like we've been doing before. Because we had some assumptions in our code, those assumptions were not held by other parts of the code, and things exploded. Okay, we are still failing in here, which is very interesting. Actually, yeah, I'm doing the wrong thing. It should be reserve stack, builder, like this. Okay, this is much better. Now we are failing at trying to encode compare, and this is not even inside Fibonacci numbers. This is happening in other parts of the code because now we have this added, and we are, where's compare? So what is compare doing? Compare, 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 compare. Yeah. So what we need to do is change things around and add another move. We probably should have some kind of function that is, I don't know, called ensure register or ensure memory or ensure something, and that will do this kind of stuff for us. But I need to think about it a bit more, so I will not do it right now. Right now, it is going to be done like this. And because we are putting at least one of them in the register, it shouldn't really matter what the other one is, and the other one is actually always a stack, which we could avoid if we only do it for immediate 64, for example. So there's a lot of optimizations that we can do, but those are not our goal at the moment. Reg S, and it actually should be A. Okay, let's check it out. By the way, if you look over here, we actually succeeded in the main goal of the video. Right now we're just doing the post cleanup. Our Fibonacci function is working, so that means that all of the stack stuff is actually working correctly, and all of the comparisons and all of the jumps and all of the returns, and we have recursion, and everything is amazing. Now there is a mismatch of operands. That's because I did not do it correctly here. We can fix that. And everything is green across the board. We've improved our move code, we improved our compare code. We are now able to refer to the function inside of its own body to do recursion. We have Fibonacci working. All is great. With that, thank you very much for watching, and hopefully see you next time.